Today's topic will be over area using definite integrals. Who am I? Greetings. I am Ernest Wilkins Jr., and I was a very prominent African-American mathematician and physicist who worked at the University of Chicago Met Lab during the Manhattan Project. I started college at the University of Chicago in 1963 at the young age of 13, becoming one of the youngest students to ever attend the university. I collaborated with Wigner on research in neutron absorption, leading to our discovery of the Wigner-Wilkins approach for estimating the distribution of neutron energies within nuclear reactors. So here, to go into more depth about our topic, here is a little background. The area under a curve between 2 points can be found by doing a definite integral between the 2 points. In order to find the area under the curve, y equals f of x between x equals a and x equals b, integrate y equals f of x between the limits of a and b. Areas found under the x-axis will come out negative and areas above the x-axis will be positive.
Some of the things you might run into before you solve for problems, you first have to identify the bigger function from the small function, the formula order, basically by either plugging in the intervals into the functions or either looking at a graph of the two functions. Next, you have to remember when integrating, you must take the antiderivative of the function instead of the derivative. When you integrate, you're working backwards and not forwards. Sometimes when it comes to solving for equation, you might have to use substitution. And when you use substitution, you're supposed to make sure you change your limits before solving for the area by taking the normal limits or the limits you start with and plugging it into the u and solving for your new limits. And another important thing to do or remember is if you have a negative constant, once you take that negative out, you flip your limits when you integrate, so you will have the right answer. On the side is an example of looking at a graph of what the bigger function is compared to the small function. What's in red is y equals x squared, and what's in blue is y equals square root of x. On top is square root of x, y equals square root of x, and on the bottom is y equals x squared. So in this situation, x squared is the smaller function and the square root of x is the bigger function.
Here's an example problem. So y equals 8 over x and y equals 2x. X equals 4 and x equals 2. The first thing you want to do is find out which function is larger. Always remember f of x minus g of x. In this case, it could be vice versa. It really doesn't matter. Just always remember bigger function minus smaller function. In this case, we're going to use the limit 4 to see which function is bigger or in which one is smaller. 2 times 4 is 8, and 8 divided by 4 is 2. So we know in this case, 2x is the largest function and 8 over x is the smallest one. So the integration of 2 to 4 of 2x minus 8 over x. Now we have our function. Now the second step we're going to do is get the antiderivative of 2x and negative 8 over x. We know the antiderivative of 2x is 2x squared over 2. And any fraction with the x at the bottom, we know that's a natural log. So in this case, the antiderivative is negative 8 natural log of x. Once we have this, we can cancel out the 2. The 2 cancels out. So now we know that is x squared minus 8 natural log of x. In this case, once we have that, now we're going to plug in our limits. It's always f of b minus f of a. Once we plug in our limits, we're going to simplify and combine all like terms. We're going to leave 8 natural log of 4 and 8 natural log of 2 as it is. But now we see that we have 16 and negative 4. We know 16 minus 4 is 12. So our answer would be 12 minus 8 natural log of 4 minus 8 natural log of 2. When it comes down to railroad application. In our new house, we have a room that needs a certain size carpet. On one side of the room is y equals x squared plus 4x plus 4. And the other side is y equals 3x plus 6. What size carpet could fit in a room? Side note, x equals negative 3 and x equals 3. So in this case, we would take the same steps. We would have to see which function is larger. So we're going to plug in 3 to see which one is larger and which one is smaller. 3 times 3 is 9 plus 6. We know that's 15. So now we're going to plug in for the top function. 3 squared is 9 plus 2 times 3, which is 6. That is 15 plus 4. That is 19. So we know x squared plus 2x plus 4 is the largest function. So the integration of negative 3 to 3 of x squared plus 2x plus 4 minus 3x plus 6. Once we get this, the next step is to find an antiderivative. So the antiderivative of x squared equals x cubed over 3. The antiderivative of 2x is 2x squared over 2. The antiderivative of 4 is 4x. Now the antiderivative of negative 3x is negative 3x squared over 3. And the antiderivative of 6 is 6x. Once you know the antiderivative formulas, solving it will not be hard. It will be very easy to convert it. Once we have that, now we're going to plug in our limits into our antiderivatives. Always remember that is f of b minus f of a. F of b minus f of a. Once we have that, we're going to solve that. We're going to combine all like terms and simplify, and our final answer would be 9. If our final answer is negative 9, but the area is sine of 9 because an area cannot be negative. Thank you for tuning in on our topic.